Okay, example one. So we're going to do three parts here. So example one, part A is, okay, so I have a rational number, 5/12, plus another rational number, 3/12. Okay, so we have two fractions. Now, if the denominators are the same, right, so out of 12 parts, then, right, we're allowed to add these guys, right? So it's another way of writing that. And 5 plus 3 is obviously 8. So we've added the fractions, right? But we can still reduce. So we can reduce, right? Or sometimes in math, that's an E. When we say reduce, we say simplify, right? We can make this look a little bit simpler. So let's see, we have 8/12. And now let's use our prime factorization techniques that we learned in 5.1 and 5.2. Well, 8, if you're not sure what that is, right? 2 times 4, that's prime. 2 times 2. Okay, so 8 is 2 times 2 times 2. And similarly with 12, you can break up 12 into any factors. It doesn't really matter. I don't know, let's just say 6 and 2. If you want to do 3 and 4, or 4 and 3, it doesn't matter. You're going to get the same factors. This is 6, so that's 3 times 2. So we get 3, 2, 2. And notice that 2 divided by 2 is obviously a big 1. 2 divided by 2 is obviously a big 1. So you really have 2/3 times 1, which is just 2/3. Okay, so I added the fractions, but I also simplified. Okay, in other words, reduce. So let's try a next part. So let's do B. And B is 7/4 minus a fourth. So this example is, again, adding and subtracting rational numbers, right, with identical denominators. So again, the denominators are exactly the same. And so I have a 4, so I know I can say 7 minus 1, and I get 6/4. But again, I can reduce this, right? You can't reduce all the time, but you have to ask yourself, can I simplify? Can I make it look simpler? And again, using prime factorization, 4 is 2 times 2, 6 is 2 times 3. Now again, you don't have to write the factor tree, the prime factorization, if you already know the factors. This is just to help you. I mean, obviously the larger numbers you're going to be using the factor tree. And again, here is our big 1, right? So that's just 3/2, and that's our final answer. And I want you to note the answers to part A, which was, so part A, we had 2/3. Okay, part B, we had 3/2. Okay, are these the same? Are they different? What's the relationship between those two? Big difference. Okay, 2/3 means, well, let's try it below it. It means out of, I don't know, 3 equal slices, right, of pizza, let's say, right, these are exactly equivalent. It doesn't look like it in the picture, right? This is, right, this is 1/3, that's another 1/3, that's another 1/3. But I have 2/3, so, right, 2/3 represents that. So you eat 2, slices of pizza out of 3. That's obviously less than a whole, right? If you shade the whole circle, that's obviously one whole. Well, the green part, I mean, it's definitely less than one whole. Okay, the next one is, let's maybe do it in blue, just to color code this. So I have 3/2. Now notice it's just the reciprocal, so I mean, it's going to be different in this case. 3/2, I mean, well, again, a lot of kind of cool things here, but notice here the numerator is less than the denominator. that's usually when that's usually means it's less than 1. When the numerator is greater than the denominator, right, it's not going to be less than 1. I mean, think about money, right? If you have $3 and you cut it in half, right, with two people, each person gets $1.50. So this represents one whole, all right, one whole pizza, right, plus another half, right? Or you can just say 1.5, right? We'll talk about mixed numbers in a bit, but this is a mixed number, and this actually, might as well write it down. This is an improper fraction. And improper fractions are basically fractions where the numerators are larger than the denominators, right? We have more than 1 here. So again, notice the pictures are different, right? This is 1.5 pizzas right here, and this is less than 1 pizza. So that's what that means. And something else that I wanted to say. I mean, you can actually draw the picture out. I mean, you can draw a pizza with 12 equal slices and then shade in the 5, and then a pizza with 12, again, equal slices and then shade in 3, right? You should get the 8/12ths, which eventually, if you cut it up into 3 pieces, it's going to be the same thing as 2/3. Again, we're going to do more practice with this, but right now I want to make sure that you understand just the procedure on how to add and subtract fractions. So let's see, I'm at 6 minutes, so let's move on to C. And C is -3 3/8. I'm going to subtract that from -1 1/8. Okay, so here we're dealing with mixed numbers. Okay, a mixed number, recall, is a number with a whole part. So ignore this negative here. A whole part, which is the 3, right? And this part, this little mixed part here. Well, the whole thing is a mixed number. So we have actually, let's write this down. So a mixed number is, so it's kind of an informal definition here, is a whole number plus a proper fraction. So for example, a whole number, I don't know, oh, well, we just worked with one, right? 1.5, right? One whole, it could be 2, 3, 4, plus a proper fraction. A proper fraction is when the denominator, when the numerator, right, is less than the denominator. So we have, right, 1/2. That's the same thing as 1.5, right? There's your mixed number. So here's our mixed numbers here. We just have some negatives, which is fine. So let's rewrite this. So -3 3/8. Okay, we know a negative times a negative is a positive, so that's plus. Okay, so in order to work with these mixed numbers, let's change them to improper fractions. Okay, so improper fractions, the trick is to multiply that 3 times 8, and then you're going to add it to that guy. But we're going to omit this for now, okay? We're not using that negative. Okay, so let's just bring that guy there, and then we work with this part, okay? 8 is in the denominator, and we have 3 times 8 is 24, right? Plus 3 is 27. And similarly, right, 8 times 1 is 8, plus 1 is 9, right? 9/8 is the same thing as 1 1/8. And again, we have like denominators, so we can write that 8. And we have, okay, so our negative will be out here. It's really -1. So we have 27 plus 9. And okay, so this is really equals, equals, equals. And then we have 8 and 27 plus 9, so that's 27, 37, 36. And here, again, we ask if we can simplify this fraction. And we can simplify this fraction, right? 8 is 2 times 2 times 2. 36, if you want to use the factor tree, right? Prime factorization, maybe 4 times 9. This is, 2 times 2, 3 times 3. So 2 times 2 times 3 times 3 is really 36. And here are my ones. And what are we left with? Well, we still have negative 1. 3 times 3 is 9. And then we just have 2 left over, right? Or 2 times 1 is 2. So that is our final answer, right? This is an improper fraction, right? Because the numerator is greater than the denominator, right? Not focusing on that negative sign in the outside. If you take half of $9, right? Half of $9 is $4.50. That's definitely greater than 1. So if you want to write even, so again, 9 halves, it's the same thing as 4.5, right, or 4.50, right? So there's your mixed number, right? You can always write a mixed number as an improper fraction, and vice versa. Okay, so those are 3 examples with adding and subtracting fractions with identical denominators, incorporating mixed numbers, and of course improper and proper terminology.